Hello everyone. In this video, we're going to be solving a really nice exponential equation from Romania. Obviously, Romanian books have a lot of great problems and I'll try to share them with you as much as possible. It's just amazing the collections that they have. Not to mention, of course, India, Russia, China, pretty much all the countries have a very good collection of problems, but especially Romania stands out. And they're very successful in the International Math Olympiads as well. Anyway, so we have 4 to the power x plus 4 to the power 1x equals 18. And I can hear you say, hey, I already know the answer. I can guess this in 5 seconds. Yes, you can. But we got to show that either there's only one solution and that's it, or there's more than one. Anyway, so let's go ahead and consider the following function. And this is going to turn into something interesting that we've done 3 days ago. So let's get started. Suppose f of x is equal to 4 to the power x plus 4 to the power 1 over x. Now, I'm going to differentiate this function, the derivative, the first derivative. This is exponential, so we can write it as 4 to the power x itself times ln 4 plus 4 to the power 1 over x times ln 4 times the derivative of 1 over x from chain rule, which is negative 1 over x squared. If you're studying calculus, definitely you should know the derivative of 1 over x by heart because it comes up quite often. So I'm going to set, as always, the derivative equal to 0 to find critical points. Not very easy to do because this is kind of like a non-standard equation where exponentials multiply by rational functions, so on and so forth. But ln 4 definitely can be taken out. So we can kind of write it as ln 4 multiplied by 4 to the power x minus 4 to the power 1 over x squared. This simplifies it a little bit. And now you can see from here, in order for this to be true, I need to set 4 to the power x equal to 4 to the power 1 over x divided by x squared. Awesome. Not so awesome, but anyways, we'll try to make it awesomer. So let's go ahead and cross multiply maybe, right? Actually, I would like to bring the 4's together. So how can I do that? How about switching these two? Since they're multiplied, they can be switched, right? X squared can be written as 4 to the power 1 over x divided by 4 to the x, which can be written as 4 to the power 1 over x minus x. Remember the exponentials? You subtract exponents when you divide powers. Easy, right? Now, this is not good enough for me because I want to make a common denominator and write this as 1 minus x squared over x equals x squared. And then I'd like to square root both sides. When you square root x squared, you're going to get absolute value and negatives are going to be involved. But let's just stay on the positive side. When I show you the graph, it is going to make more sense why I picked it, because we're going to resolve this at the end, all right? So what am I going to do? Square root both sides. 2 to the power 1 minus x squared over x equals x. And then raise both sides to the power x. And guess what? This is the exact same equation that we have handled 3 days ago, right? On September 23rd, to be exact. Okay, so this is my equation. And as you should know, this has a solution at x equals 1. All right. Right? This equation has a solution at x equals 1. But that's just a derivative. That's not the original equation. Remember that. It just tells us that we have a critical point at 1. And if you look at the derivative carefully, so I kind of examine what's going to happen to the right of 1 and to the left of 1. If, for example, if x is greater than 1, the first derivative is going to be positive. Shouldn't be too hard to see because you're going to have a smaller expression being subtracted from a larger expression. Think about it like 4 to the second power minus 4 to the power 1/2 divided by 2 squared, which is 4. So that's going to be positive, right? So if x is greater than 1, then f prime is positive, which means our function is increasing. Otherwise, it is decreasing, which means our function is increasing on 1 comma infinity. So now, think about this. You have an increasing function on an interval, and it's being intersected by a horizontal line, which is y equals 18. How many solutions you're going to get? Only one, right? So we have a unique solution. We have a unique solution on 1, infinity on that interval, and that happens to be what? How do you find that solution? At this point, you can definitely guess and check, and it shouldn't be too hard. I know you've done that before. So that's going to be, think about powers of 4. How about 16 plus 2, right? And that's going to be x equals 2. Because 4 squared is 16, and 4 to the power 1/2 is square root of 4, which is 2. Great. So x equals 2 works, but is that the only solution? That is the $1,000,000 question. So here's the idea. If x equals x sub 0 is a solution, then x equals 1 over x sub 0 is also a solution. Now, why am I saying that? Let me explain real quick. We have 4 to the x plus 4 to the power 1 over x equals a constant. Now, if you replace x with x sub 0, we don't care what the solution is, but you can also do it with 2, by the way. It's easy to see. But notice that if I replace x sub 0 with 1 over x sub 0, this is just going to be 1 over 4 to the power 1 over x sub 0 plus 4 to the power 1 over 1 over x sub 0, which is the reciprocal of the reciprocal, which is x sub 0. It's going to be the same thing. They're going to be equal. Therefore, if x equals 2 is a solution, then x equals 1/2 must also be a solution. And are there any other solutions? No. But let's go ahead and take a look at the graph and get a better idea how these functions behave. Now, I graph both of these functions. And by the way, the graph of 4 to the power x plus 4 to the power 1 over x is a very interesting graph because it kind of behaves really weird on the left-hand side. So here's the idea. Exponential functions normally like going to be constantly increasing or decreasing, but this is kind of like the sum of two weird functions. So this has another minimum, so it has 2 minimum actually, but that is for the negative value. But it doesn't, you don't have to worry about it because as x approaches negative infinity, you can tell what the limit is going to be, right? Hopefully. As x approaches negative infinity, this is going to approach 1 over negative infinity, which is 0. So that's going to approach 1. This is going to approach 0. Therefore, our function is going to approach, okay, let me write it. So I'm just talking. So limit as x approaches negative infinity of f of x is going to be 1. So it's never going to intersect y equals 18, no way. But the positive piece is going to intersect, and it's going to be at 2 points. And they're going to be 2 and 1/2. They're reciprocals. Is it always like that? Something to think about. And of course, if one of the values is a solution, the other one is also a solution. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.